We are reviewing, refresh your memory on how to solve them, write the equations, and our applications of quadratics, which were our word problems, okay? So don't forget, when it comes to solving quadratics, there's 3 different ways. One way is factoring. What's the other way?
Completing the square.
Completing the square. And what's the last way? Quadratic formula. Don't forget, you can always solve close to any equation using your calculator as well to graph it. Okay, don't forget that's also an option. But basically, when you're solving with the quadratic, you're trying to find its x-intercepts. Not every quadratic will have an x-intercept, but if it does, it will show up when you solve it. Remember, when you're factoring, your most basic ones, you're looking for 2 numbers that what? Add and multiply. Add to give you what? -5, your B term, and then
multiply to get your C term.
Multiply to give you your C term. What are those 2 numbers?
7, 2.
Which one's negative?
-7.
-7. So that'd be x minus 7, x plus 2. And then to solve them, you would set both of those factors equal to 0 and solve. What are my 2 solutions? 7 and -2. Very good. When over here, when a is not 1, what do you have to do? Multiply your a to your c. So that's going to give me -40. So now I'm going to do what? How so?
Well, you do.
-40 as your number, so that's what you multiply by?
Multiply to get
So you multiply to get -40, but add to give you what?
6.
6. So still your b. That still is still there. What 2 numbers?
10, -4.
10 and 4. -4?
4.
And then what do you do from there?
Put 5 on top.
Put a 5. I'm going to put a 5x since we're going to end up factoring it from here. What do I do?
5x.
Simplify. That 5x over 10 simplifies down to be what?
x plus 2.
X plus 2. Can this one simplify?
No.
Nope. So 5x minus 4. Again, you set those factors equal to 0. So that's x plus 2 equals 0. 5x minus 4 equal to 0. And you'll have your 2 solutions of -2 and +4/5.
There we go.
Okay? How can you check to see if you factored correctly?
Plug it back in.
You can plug it back in. Yeah, I mean, well, that's one way you can check to see if your solutions are correct. But what about your factors? How do you know if you factored correctly? You multiply them, you FOIL them. Okay? By foiling, you'll be able to see if you did well. Okay? Who remembers the quadratic formula?
I do.
What is it?
-b plus or minus
Plus or minus?
Square root of 4e
squared
b squared minus 4ac
minus 4ac over
All over 2a. Yes, because not every quadratic is factorable. Factoring only works some of the time. However, quadratic formula and completing the square, which we'll go over next, will always get you your solutions to a quadratic. You just want to make sure, though, that before you start going to plug in, what needs to be true about the quadratic?
It needs to equal 0.
It needs to equal 0. So how do I get this equal to 0?
Subtract 5.
Subtract the 5 over, and then I can plug into my quadratic formula from there, because there aren't 2 numbers that multiply to give you -15 that add to give you 10. If I try to factor this. What's A? 3. What's B? And what's C?
-5.
Go ahead and plug in the quadratic formula, and let me know what you get.
Is that it? Is that all I need? How did you get 5?
So you should have plugged everything in. That gives you -10 plus or minus the square root of 160 over 6. No?
Yeah.
Yes.
It does.
All right. Then we need to simplify. 160 breaks down to be what?
4 square root of 10.
4 square root of 10. Good stuff. Can I simplify from here?
Divide everything by 2, the coefficients.
So your final answer is -5 plus or minus 2 square root of 10 all over 3.
Yay!
Yes. Good job.
Cool.
Okay. Let's review completing the square. There were some steps.
Garrett knows how to do this.
I did not have to do this. Ooh.
What are my steps when it comes to completing the square? You want to make sure what?
No A.
There is
No A.
no A, like no extra number. A needs to be 1. And then on top of that, what else?
0. Equal to 0.
needs
Or you don't have to.
Not equal to 0 when you're solving.
What's the extra then?
Oh, you need to divide b by 2 and then square it.
There's one more thing before we can do that.
Oh, and make sure the
Let's put the 5 over.
non-variables are together.
You need to make sure the non-variables are together. So like the 49 and the 5, they need to be together and they need to be on the side by themselves. Okay?
So subtract 49.
So you need to make sure C is by itself. You need to make sure that A is 1. Okay? So yes, you would subtract over the 49. So then you have x squared minus 14x equals negative 44. Okay? So then from there, that's when you can now complete the square. By doing what? Dividing what by 2?
B.
And then
Squaring that.
and then squaring it.
Adding it to both sides.
And then add it to both sides. So we take half of 14, negative 14, which is,
-7.
and then we square it, and that is,
49.
so we add 49 to both sides.
Wait, completing the square is how you find vertex form?
It is one way you can find vertex form, but it's also used to solve. Yeah.
Alright.
But when you are solving versus when you are writing in vertex form, you're solving so you would add to both sides. But when you are vertex form, you would subtract, everything would all be on one side, and you would subtract that second number. That second square.
Oh, completing the, I mean, you could technically still do it that way, and you can have it on the other side.
And then bring it over here.
Yeah. What the heck?
After you do this, what do?
You turn it into the factors.
Turn into the factors,
Yes.
and then pretty much solve from there. Okay? So this becomes x
Plus 7 minus 7.
X
Wait.
minus 7 squared.
x minus 7 squared. Remember, whatever number comes here is what you get when you take half of b. And then what's negative 44 plus
5. Not plus 5. Yes, 5. There.
So then I need to take the square root. So don't forget your what when you take the square root.
Plus or minus.
And then you'll have x equals 7 plus or minus the square root of 5. Y'all remember it?
I remember more than I thought I did.
Yeah.
Good. Keep on trucking. Quadratics was a pretty thick unit for the beginning ones. On your desk, I want you guys to solve this using completing the square. Okay. You want to make sure that A is 1, so you have to divide everything by 10. So that's x squared plus, I'm going to go ahead and reduce this to 2/5, and I'm going to reduce this to 1/2. Then you want to make sure that C is by itself. So then that means I'm going to add over 1/2. Now it's time to complete the square. So you take half of B. What's half of 2/5?
4/5.
Shoot. Because if you
If you keep,
change
change, flip, it should be 2/10, which is 1/5. Then you square it to get
1/25.
1 over
I
25.
looked at the wrong.
Mhm. So then from here, you square this. So remember, inside of the parentheses is
1/5.
1 over 5, the value you get when you take half of b. And then over here, to add these two, you need a common denominator. What's the common denominator between 2 and 25?
50.
50. So 1/5 needs to be multiplied by,
25.
and 1/25 needs to be multiplied by 2. So then this becomes 27 over 50. How do I solve this? Take the square root. And remember, when you take the square root of a fraction, you're taking the square root of the top and bottom. Simplify the numerator. What does that become?
3 square root of 3.
Simplify the denominator. What does that become?
5 square root of 2. But you have to both multiply the numerator and denominator by square root of 2.
Exactly, because you need to rationalize. So really and truly, this is, go down, sorry, there you go. X plus 1/5 equals plus or minus 3 square root of 6 all over
5.
10. Because square root of 2 times square root of 2 is 2. 5 times 2 is 10.
Cancel out.
Then the last thing for our final answer, we just
Subtract the 1/5.
subtract the 1/5. So, yep, not our prettiest.
Can we just do, would this be the easiest way to do it? Or
No.
would we do quadratic
Quadratic formula.
That's not it.
Yeah, but I just want to make sure you guys practice the skills of completing the square. Okay?
Both is good.
So make sure A is 1 by dividing out that term. Make sure C is by itself, and then go through the process of completing the square. Yes, this one was a doozy, but I want you guys to have that practice of doing a little bit of algebra, rationalizing denominators, simplifying radicals, adding unlike denominators, etc., etc.
You tricked us.
Now I wanted y'all to work. It doesn't work.
She wanted to say a lot of stuff.
You let my father.
Oh.
Alright, here we go. Discriminant was another part of quadratics. What was the formula for discriminants?
Negative 4a. Wait, no. B squared minus 4ac.
B squared minus 4ac. That part that's underneath the square root in the quadratic formula. Okay? That part that's underneath the square root in the quadratic formula. When the discriminant was greater than 0, what does that mean?
It had one roots.
It did deal with the roots.
It had more than one root. It had 2 roots.
2 what? What was special about those roots?
Real roots.
They were 2 real and 2 distinct roots.
Yeah.
What about when the discriminant equals 0?
You have no. You have one real root.
system.
One real solution, a root, also known as a double root. But when it's less than 0,
No real solutions.
no real ones. They were imaginary. Because remember, the discriminant is the part that's underneath the square root. So you can't have a negative underneath the square root. Otherwise, there'd be imaginary solutions, imaginary roots. Questions? So these were ways to describe the roots, describe the solutions, but also it could be used to find different pieces of a quadratic equation, such as this one. This is more like the type of IB problem that you would deal with. Not so much like, hey, here's a quadratic. What's the discriminant? No. You have a quadratic that's 4x squared plus 4kx plus 9 equals 0, and you're asked to find k when that quadratic has 2 distinct solutions. 2 distinct means that the discriminant is what? Is greater than 0. So b squared minus 4ac is greater than 0. Anytime it talks about the types of solutions or the types of roots, you know you're going to be dealing with the discriminant. What's b in this problem?
4K.
4k. So you need to square 4k. What's a?
4.
4. And what's c? 9. And so then from here, you basically need to solve for k. Can you guys go ahead and solve for k? Don't forget with quadratics and inequalities, you can't just say like, okay, once you solve it, you can't just say like, oh, okay, well, k is equal to the numbers because it's 9 equations to inequality, okay? So when you square that 16k squared minus
144.
144, you continue to solve it like it's a normal quadratic equation. What's that? You divide by 16. 9. Now you have to take the square root. Now you still get plus or minus 3, but you can't say that k is greater than or equal to 3 and greater than or equal to negative 3. No, that basically means that, okay, you have negative 3 and positive 3. You're looking for the values of k so that you'll have 2 distinct solutions. Is it the values in between negative 3 and 3, greater than positive 3, or less than negative 3? This is where the number line came into play. Because you're looking for all the values of k that could give you 2 distinct solutions. Okay? What's the number that's less than negative 3?
Negative 4.
You plug it in to see if it's going to give you a value that's greater than 0. Sorry. Greater than. Is this going to be a number that's positive, greater than 0? What's negative 4 squared?
Where do you plug negative 4 into?
Yes, it's positive.
It is, because it's going to basically be 16 times 16, which is 256. 256 is bigger than 144, so it's going to be positive. So that's what you want. You want all the values that are less than -3. What's the number that's in between -3 and 3? If I plug 0 in here, is that going to be positive or negative?
Negative.
So it's going to be negative, which means that this won't work. None of these will give you a discriminant that's going to give you two distinct solutions. And if I plug in +4, that will work. So the values of k that will give you two distinct solutions are the values that are less than -3 and greater than 3. This only happens, well, you do a number line a few other different places, but whenever you have a quadratic inequality, you're looking at a range of values. Whenever you're given a quadratic inequality, you're looking at a range of values. Okay, and if anything, this is like your more difficult discriminant type of question that you can get. Okay? Questions on this?
There's no equal to, just greater than?
Yeah, it's no equal to.
When does the sign flip?
Whenever you divide by the negative number. Or
Only a
multiply.
negative number?
Like the inequality? Yeah. It's like when would you switch the sign? So like if this is a -16 and I had to divide by -16, this would change. Alright. Last little bit of information about quadratics before we actually get to the applications part are your different forms for a quadratic. You have your standard form, ax squared plus bx plus c. It can either equal y if we're dealing with a function, or it can equal 0 if we're solving. Remember, standard form always told us the y-intercept very easily, 0c. We also had a formula for the axis of symmetry, which was -b/2a, and that was the only thing about quadratics that was given to you. So discriminant was not given to you. You had to remember that. Only x equals -b/2a. And it is an equation. Do not forget the x equals. You have vertex form, y equals a, x minus h squared plus k, where h and k are the vertex of the parabola, hence why it's called vertex form. And then the x-intercept form, aka factored form, y equals a, x minus p, times x minus q, where the graph crosses the x-axis at p0 and q0, hence why it's called x-intercept form. To find your axis of symmetry, it would still be an equation x equals p plus q divided by 2. Because remember, since a quadratic is symmetrical, if you know what your x-intercepts are, your axis of symmetry is halfway. And remember, the axis of symmetry is the line that cuts the parabola into two equal pieces. And the a in each one of the forms is the same a, okay, across the board. So if you were able to write your quadratic in x-intercept form, that a would be the exact same a if you were to write it or to convert it to standard form.